Hey everyone, I hope all of you are well. So in my last video we have completed the chapter comparing quantities, and today we are going to start the chapter rational number, that is chapter 9. Okay. So what is the definition of a rational number, how to find them, we will find these all in this chapter. So already we have learned what is rational number in class 6. Let's try to remember again. The number which can be written in the form of p by q, where q not is equal to 0, and p and q must be in their simplest form, means their HCF will be definitely 1 always. Okay, suppose I am writing 1 can be written as 1 by 1. Here it is in the form of p by q, where q is becoming 1, which is not is equal to 0. So 1 being a whole number, being a natural number, being a rational number. Okay, so whatever the natural numbers or whole numbers are there, all of them can be represented in the form of rational numbers. So all of them are rational numbers. So as 0, suppose I am taking 0 by 5, which is also becoming 0. 0 by 5 means it is in the form of p by q, where q is becoming 5, where q not is equal to 0, means 0 is also becoming a rational number. So in this way we will understand the rational number. Now here we will solve the exercise problems and we will understand the whole chapter by solving those problems. Okay. Now see, let's start exercise 9.1. Since it is a very easy chapter, that's why we will not take much time for finishing this. So let's start. In question number 1 it is written least 5 rational numbers between -1 and 0. Okay, this is the first question. Now understand it very well. See, -1 and 0. In between these two rational numbers, we will get so many rational numbers. Okay, whatever the proper fractions will be there along with negative sign will be such rational numbers in between -1 and 0. Now see, there is a specific way of finding this. See, here in the question it is asked you have to find 5 rational numbers. So we will try to convert these two numbers as a fraction having the denominator 5 plus 1, that is 6. Suppose I am writing it here in this way, -1 by 1. -1 can be written as -1 by 1. If we multiply both the numerator and the denominator by the same number, we will get the equivalent fraction of this. We have already learnt it in class 6, that both the numerator and the denominator can be multiplied by a same number, then we will get the equivalent fraction. So the same thing we have done here. So here we are getting -6 by 6. And for 0, we can write it in this way, 0 by 6. Now, the numerator will be reduced and will be continued to 0. Okay. See, just before -6, we are getting -5 by 6. It is a fraction, it is a rational number between 0 and -1 as well. Just before -5, we are getting -4 by 6. This is also a rational number between 0 and -1. Just before -4, we are getting -3 by 6, which is also a rational number between 0 and -1. Similarly, we are getting -2 by 6 and we are getting -1 by 6. So all these are the rational numbers having the denominator 6, you can see, and most importantly, these all rational numbers are staying in between these two rational numbers, 0 and -1. Okay. So in this way we will do all the sums. Let's come to the next sum. Here you have to find the rational numbers between -2 and -1. But here again you have to find 5 rational numbers. So again the denominator must be 5 plus 1, 6. So these two numbers will be converted to such a fraction where we will get the denominator 6. Okay. So let's take it in this way, -2 by 1. -2 will be multiplied by 6, 1 will also be multiplied by 6. So it is coming as -12 by 6. And for this one, how to do? -1 by 1 again, minus 1 into 6 divided by 1 into 6, and it is coming as minus 6 by 6. Now you have to find the rational numbers between these two fractions or these two rational numbers. How to do? Very easy, just like the previous sum. Just before this we are getting minus 11 by 6, then minus 10 by 6, then minus 9 by 6, then minus 8 by 6, then minus 7 by 6. Exactly in this way we will do all these fractions or rational numbers, okay, which will be lying between these two numbers which are given in the question, and these two rational numbers are represented in this form. For our convenience, we have converted these fractions. We have found the rational numbers having the denominator 6, okay, so that the calculation will be a little bit easy. Let's come to the next one. In question number 3 it is written 4 by 5 and 2 by 3. Now here you don't have to do anything, okay. The first step what we have to do is you have to find the LCM of these two denominators, that is 15. Now very easy, 4 by 5 will be converted to such an equivalent fraction so that we will get 15 as the denominator always, okay. Similarly for this one, 2 by 3, it can be written as 2 into 5 by 3 into 5, which is coming as 10 by 15, okay. Now see, if we want to calculate this in the previous way, we are only getting one number or one rational number between these two, which is 11 by 15, but we have to find 5 like that. So it will be better if you just take the next multiple of 15, okay. See how to do this. We are just changing the numbers. 15 will be converted to 30, 5 will be multiplied by 6, similarly 4. Here 3 will be multiplied by 10 and 2 will again be multiplied by 10, so it is coming 20 by 30, it is coming 24 by 30. Now I hope you will get 3 of them, isn't it? You will get 3 rational numbers in between them, that is 21 by 30, 22 by 30 and 23 by 30. 2 more are left. Now what you have to do? The same procedure, or else you can also find it as the multiple of 15, that will be 45, okay. Now for making 5 45, we will multiply it by 9 and you will multiply it by 15. So as the numerator will also be multiplied by 15 and here also it will be multiplied by 9. So here in this case you are getting 36 by 45, here you are getting 30 by 45. Now I think you will get, because the rational numbers between 30 by 45 and 36 by 45 are 31 by 45, 32 by 45, 33 by 45, 34 by 45, 35 by 45. So these are the 5 rational numbers between these two rational numbers which are given in the question, okay. So this may be one procedure of doing this. I will show you another procedure of doing this. So the another procedure is just add these two numbers and divide it by 2. Addition and divided by 2, okay. Let's do one of them. 4 by 5 plus 2 by 3 divided by 2, okay. So you will get such a number which will be exactly in between these two numbers, okay. Let's calculate it, okay. Now again you can find such a number which will be exactly in between this number and this number, okay. How to find this? 20 by 30 plus 4 by 5 divided by 2. So you will get such a number which will be exactly in between these two numbers. Again you can just add these two rational numbers, 2 by 3 and 22 by 30, and you can divide that sum by 2 and you will get this number which will be lying exactly in between these two numbers, okay. In this way you can find innumerable number of rational numbers between two rational numbers, okay. So whatever the way will be convenient for you, you can use that, but the best way is just find the LCM. If you are getting the numbers, then it is okay. If you are not getting the numbers, then find the multiple of the LCM, then make the denominators equal to the LCM for finding the equivalent fraction of that rational number, and you will find the rational numbers 5, 6, 7, 8, any number of natural numbers, whatever you are willing to find in between these two rational numbers. Let us do this one. Minus 1 by 2 and 2 by 3. Okay. Again see 2 and 3, which is coming as 6. Okay. The LCM is coming as 6. So for taking a safe side, I am taking this as 12. The multiple of 6, which is 12. See, minus 1 by 2. It will be converted to an equivalent fraction where the denominator must be 12. So it is coming as minus 6 by 12. Okay. And for this one, 2 by 3, again the denominator will be converted to 12, and let's convert it. It is coming as 8 by 12. Okay. You could have taken 6 also. Okay. Both will be correct, but you have to find 5 rational numbers. That's why I am taking this safe side. Now for minus 6 by 12 and 8 by 12, how to find this? Just before this, we are getting minus 5 by 12, then minus 4 by 12, then minus 3 by 12, then minus 2 by 12, then minus 1 by 12, then 0 by 12, isn't it? Then 1 by 12, then 2 by 12, then 3 by 12, then 4 by 12, isn't it? See, this is a negative rational number, this is a positive rational number. So definitely in between these two we will get 0, which is also a rational number, isn't it? In this way we will find. Okay. See, I have shown you so many rational numbers here. So this is the way of finding. Now choice is yours that in which procedure you are willing to do. Let's come to the next question. In the next question it is written, write 4 more rational numbers in each of the following patterns. See, question number 2, 1. The patterns which are given: 3 by 5, 6 by 10, 9 by 15, 12 by 20. Isn't it? See, very easy. It is becoming 3 into 2 by 5 into 2. It is becoming 3 into 3 by 5 into 3. It is becoming 3 into 4 by 5 into 4. So definitely the next will be 3 into 5 by 5 into 5. Next 3 into 6 by 5 into 6. Then 3 into 7 by 5 into 7. 3 into 8 by 5 into 8. 3 into 9 by 5 into 9. In this way we will find so many rational numbers just following this pattern. Okay, exactly in this way we will find. So it is coming as 15 by 25, next 18 by 30, next 21 by 35, next 24 by 40, next 27 by 45. Okay, so in this way we will find the rational numbers. Let's come to the next sum. Let's do the fourth one next, because question number 2 and 3 will be your homework. Okay, so question number 2, 4. 2 by 3, 2 by 3, 4 by 6, 6 by 9. Very easy. 2 by 3, 2, 2 by 3. Here if 2 is multiplied by 1, 3 is also multiplied by 1. Here 2 is multiplied by 2, 3 is multiplied by 2. Here 2 is multiplied by 3, 3 is multiplied by 3. So this pattern is being followed. So let's do the next one. 2 into 4, 3 into 4, 2 into 5, 3 into 5, 2 into 6, 3 into 6. Exactly in this way we will continue. And it is coming as 8 by 12, 10 by 15, 12 by 18. In this way you will find the rest of the rational numbers. Okay. So your homework is you will find 3 more rational numbers. Okay. Now let's come to the next one. So in question number 3 it is written, give 4 rational numbers equivalent to. So whatever we have done till now in question number 2, all these are equivalent rational numbers. Okay. So I will do this one, you will do these two. Okay. 4 by 9. Very easy. 4 into 2 by 9 into 2. 4 into 3 by 9 into 3. 4 into 4 by 9 into 4. 4 into 5 by 9 into 5. Why am I doing so? Both the numerators and the denominators can be multiplied or can be divided by the same number, so that we will get the equivalent fraction as well as the rational number. So it is coming as 8 by 18. It is coming as 12 by 27. It is coming as 16 by 36. It is coming as 20 by 45. Okay. So your homework is you will find 5 new equivalent rational numbers. Okay. For this, and these two will be your homework. Just multiply the numerator and the denominator, both of them by the same number, okay, and you will get the equivalent rational numbers. Let's come to the next one. In question number 4, draw the number line and represent the following rational numbers on it. It was also done in class 6. So let's do, or let's revise it, 3 by 4. How to do this? Very easy. 3 by 4 is a proper fraction, so it lies between 0 and 1. Okay, 0 can be written as 0 by 4 and 1 can be written as 4 by 4. Okay, so in between these two rational numbers we are getting 1 by 4, next 2 by 4, next 3 by 4, and here our answer comes. This one is our answer. Okay, so in this way we will write this. Let's come to the next one. I am doing question number 4, you will do the rest of 2. 7 by 8. Again the same procedure, it is also a proper fraction. So this fraction lies between 0 and 1. 0 can be written as 0 by 8, 1 can be written as 8 by 8. So in between these two rational numbers, how to find the rest of the rational numbers? 1 by 8, 2 by 8, 3 by 8, 4 by 8, 5 by 8, 6 by 8, 7 by 8, and here we are getting 7 by 8, which is asked in the question. In this way we will find this. Okay, the rule is whatever the denominator will be given, first you have to find whether the fraction is given is proper fraction or improper fraction. Okay, if it is a proper fraction, it must be lying between 0 and 1. If 0 and 1, then it is very easy. 0 by 4, here we are getting the denominator 4 in the given question. So we will divide both the denominators by 4 first. Both the numerators, we will multiply both the denominators by 4 by keeping 1 as the denominator. We will multiply both the denominators by 4 and both the numerators will also be multiplied by 4. Okay. Here in this case, both the denominator and numerator are multiplied by 8. Exactly in this way we will do the sums. Let's come to the next one. So in question number 5, it is written the points P, Q, R, S, T, U, A, B on the line are such as TR is equal to RS is equal to SU, C minus 1 minus 2. Okay, all these line segments are same in length. Okay, next, and AP is equal to PQ is equal to QB. Okay, name the rational numbers represented by PQRS. PQRS, these 4 rational numbers will be found. Okay, so how to do this? See, we are drawing just these two parts. P, R, S, U. T is represented by minus 1, U is represented by minus 2. And for this part, A, P, Q, B. B is represented by 3, A is represented by 2. Okay. Now your work is, you have to find this P, this Q and this R and this S. How to do this? Provided the information is given US is equal to SR is equal to RP. Similarly, AP is equal to PQ is equal to QB. Now the way what you are doing is, the first step, what is the length of TU? TU is equal to minus 1 minus 2. Okay, and it is coming as 1 unit. So this part is completely 1 unit. Okay, so definitely each of the parts will be 1/3 unit, isn't it? See, the whole part is 1 unit. We have found it. So this part will be 1/3, this part will be 1/3, this part will be 1/3. In this way we can do. Okay. Now the way is, for finding this, we will do minus 1 minus 1 by 3. So it is coming as minus 4 by 3. Now for doing this, we will do the same thing. Here we are getting minus 4 by 3. So here we will write minus 4 by 3 minus 1 by 3. So it is coming as minus 5 by 3. So in this way we have found the S and we have found the R. Okay. These 2 points are represented by these 2 rational numbers, minus 4 by 3 and minus 5 by 3. Okay. Now see, we have done this in this way. Let's come to this one. So first we can find that how many parts are there. 1, 2, 3. We are getting 3 parts here. Okay. So the length of AB is 3 minus 2, that is 1 unit. Again the same thing, this will be 3 minus 1 by 3, this will be 3 minus 2 by 3. So these two will be the rational number which are representing these two numbers P and Q. So in this way we will do this. Let's come to question number 6. Which of the following pairs represent the same rational numbers? See, this one is very easy. Without watching anything we can see that these two numbers are same, 5 by 9 and 5 by 9. These two are same rational numbers. Let's check this one. 6, 4. 3 by 5 and 12 by 20. Yes, you can understand. 3 into 4 by 5 into 4. Isn't it? So these are equivalent rational numbers. So these two are representing the same rational numbers. Okay. Now let's check this one. 1 by 3 and 1 by 9. See, the numerators are same, but the denominators are different. So definitely they are not same. Okay. Let's check this one. 8 by 5 and 24 by 15. Here you can see 8 into 3 by 5 into 3, and here it is coming this. So these two are equivalent rational numbers, so these can also be called as equal rational numbers. So rest of you will do yourself because these are very easy sums. Let's come to the next one. Rewrite the following rational numbers in their simplest form. Again very easy. These two sums I will do and these two will be done by yourselves. So question number 7, 3. 44 by 72. Let's start reducing it by 2. 22, 36. Again by 2, 11, 18. Can it be done again? 11 by 18. No, these two are the co-prime numbers. So simplest form of this rational number 44 by 72 is 11 by 18. Let's come to the next one, 8 by 10. Let's reduce it by 2, 4 by 5. It is coming as 4 by 5, which is the simplest form again because numerator and denominator are co-prime numbers. So in this way we will do. Very easy sums, we have already done this. Okay, let's come to the next one. Fill the boxes greater than, less than and equal sign. Very easy. See, I will do one sum and you will do the rest of them. Let's do this one. 1/3 and 1/4. Which sign will be put in between these two? The procedure is numerator 1 into denominator 2. 1 into 4. Again, denominator 1 into numerator 2. Okay. So here you can see this product is coming as 4, this product is coming as 3. So this product is coming as 4, this product is coming as 3. 4 is greater than 3. So it is very clear that this fraction 1/3 will be greater than this fraction. So here you will put greater than sign. By checking this one we can understand these two are equal. Okay. And here 0 and 7 by 6. 7 by 6 is an improper fraction. So it must be greater than 0. Let's check this example. 8 by 5 and 7 by 4. Again the same procedure. First numerator into second denominator, 8 into 4. First denominator into second numerator. So it is coming 32, it is coming 35. So 35 is greater than 32. So definitely 7 by 4 is bigger than 8 by 5. Okay. Now in this way we will do the rest of the sums. Let's come to the next one. Here again the same type of sums are given. Which one is bigger? Okay. By cross multiplying only you can understand. In this way the first numerator into the second denominator, you will check the product. The first denominator into the second numerator, you will find the product and you will check. Okay. So all these questions will be your homework, same as the previous one. Okay. Let's do question number 10. Which of the following rational numbers are in ascending order? Let's check this one. 3 by 5, 2 by 5 and 1 by 5. Ascending order means from smaller to greater. As we have already learned, if the denominators are same, then the numbers can be arranged on the basis of the numerators. If the numerators are bigger, then the fraction will be bigger. If the numerators are smaller, then the fraction will be smaller. Okay. So here you can see 3 2, 1. So it is given in descending order, just because all the denominators are same. That's why we are checking the numerators only. 3, 2, 1 means in descending order. Okay, let's come to the next one. Minus 1 by 3, 2 by 9 and 4 by 3. Okay, you have to check whether it is in ascending order or not. Minus 1 by 3 is less than both of these two rational numbers. It is very clear. So we have to check these two. Okay, as I have told, 2 into 3 6, 9 into 4 36. So this one is again smaller than this one. So you can also see that this fraction is smaller than this fraction. So it is given in ascending order. 2 by 9 is smaller than 4 by 3. Or else you can also check this in this way, because 4 by 3 is an improper fraction and 2 by 9 is a proper fraction. So definitely this proper fraction must be smaller than this improper fraction. Okay, so in this way we will do. Let's come to the next one. 3 by 7, 3 by 2 and 3 by 4. See, this type also we have done. 3 by 7, 3 by 2 and 3 by 4. Here in the previous case we have learned, if the denominators are same, then we will check the numerators. If the numerators are bigger, then the fraction will be bigger. But here exactly opposite. Here the numerators are same. Okay, so the smaller denominator will be the greater fraction. Okay, the smaller denominator will be the greater fraction. The smaller denominator will be the greater fraction. So here the smallest denominator is for this 3 by 2. So this will be the greatest number. Then from this, the smaller one is 3 by 4. This will be smaller than this, and this will be the smallest one. So this is the proper descending order, or you can write it inversely. So you will get the proper ascending order. Okay, so it is not given in proper ascending order. So today up to this class, in my next video we will start the operations of the rational number. Till then, stay safe, keep studying. Okay, bye everyone.